All right, good morning. This is Mrs. Rondo. We're going to look at distance, some things with distance moving forward. If you will set up a new page of notes, you can call it finding length or distance. There's your essential question, and you don't need to write down the learning goal, but our goal is that you can prove two segments are congruent using their lengths. I'm going to go ahead and move forward. Feel free to pause the video so that you can write that down, but I'm going to keep the video going. All right, so we're going to start with Pythagorean theorem. And again, if you need more time to write this down, please pause the video and write it down. This is just a review in case you have forgotten what Pythagorean theorem is. So I'm going to start at the top with my triangle up here. This is a right triangle because it has an angle here that is 90 degrees. That's what that little box means. And then also across from the 90-degree angle, we have this side, which is called the hypotenuse, and we label it with a C. So the C on a right triangle is always the hypotenuse. And we see that in our formula over here that we'll get to in a minute. All right, so we have the 90-degree angle makes it a right triangle, and across from that is the hypotenuse C. These other sides are just called legs or sides of the triangle. And so what we have in Pythagorean theorem is one leg, the length of that leg is squared, plus the other leg. That length is squared equals the hypotenuse squared. Okay, so a squared plus b squared equals c squared. We will need that today. All right, so we're going to do just two quick examples. Find the missing side. So in this case, on this triangle, my missing side is the hypotenuse. This is my, even though it's called x, this is my c of a squared plus b squared equals c squared because it is across from the 90. So when I set up my equation, it doesn't matter which number for my legs, I make the a or the b. So I'm going to call this 4 squared plus 6 squared equals x squared. So I made the 4 the a, 6 is the b, and x is my c. Then if I solve this, I'm going to get not 24. Oh, dear heavens. 4 times 6, not 4 times 4. All right, 4 squared, let's try that again, is 16 plus 36 equals, if I do that math quickly, I believe that is, well, hold on, x squared, leave the x squared alone. Goodness, goodness, goodness. Okay, now let's do 16 plus 36. I get, it looks like 52 equals x squared. Now I need to actually find out what x is, so I'm going to move this over here, and I'm going to say 52 equals x squared. Then to undo the squared, I would square root both sides, and that will give me my x. On the left-hand side, my square root of 52, if it's possible, we should break it down. So I'm going to see if I can break that down. 52 would break down actually into 4 times 13, which is not something I would normally expect you to know, but definitely could try it. And 4 is a perfect square. We know the square root of 4 is 2, and then we're left with the 13 inside. So I'm going to move that x down a little bit. There we go. So we would end up with an answer of 2 times the square root of, I don't know why I'm putting a square root in there. Let's fix that. 2 times the square root of 13. That gives us our answer. Now, if you are doing, depending on what kind of activity you were doing, you might be asked to actually find an answer for that. And since I wasn't quite ready, I will do it quickly on my phone. But you can decimal approximate that answer. And so that result would be, looks like, come on, pen. If you did a decimal approximation, it would be 7.21. The 1 repeats for a little while, so we'll call it that. And actually I said equals, but it's not equal, it's an approximation. So this really should be an approximate symbol. So either answer, it depends on the context as to why you would use whatever, which answer. Sometimes we would want the square root version, and sometimes we would want the decimal version. All right, let's take a look at the second one. This time My x is not the hypotenuse. My hypotenuse is over here. That's this one. That's the C. So it doesn't matter which leg I use for x. So I'm going to make it my A, or my first one. So I'm going to say x squared plus 10 squared equals 15 squared. So that represents my 2 legs squared equals my hypotenuse squared. And I'm going to simplify. 10 squared gives me 100. 15 squared, I believe, is 225. And then to solve for x squared, I would subtract the 100. I get x squared equals 125. And then I would square root to undo the squared. And I get x equals 125 is not a perfect square. So I'm going to try again and break it down. And it will break down. So I'm going to move my x. I'll put x back in a minute. Sorry, I don't want an equal sign yet. I want to break down 125. So that would be 5 times 25. This is going to be 5 times 25. And 25 is a perfect square. So I know the square root of 25 is 5. So I would have the square root of 25 is 5. And then left over, my other one that's left over stays inside the root. So 5 times the square root of 5 would be my result. These 5s aren't very pretty, so I have to fix them. It's very important that I fix them. See if I can do that a little bit nicer. That's better. And then my answer, of course, being x. And that gives us a couple of examples. Make sure to save these notes because we are going to add to them in the upcoming days. So we will be adding to these notes. They are not finished. Make sure to save them. And we will come back and add some more examples here. But for now, that is it.